These next questions are kind of like solving puzzles. And so what they're going to get you to do is try to take single logarithms that are the log of something not specifically 2 or 3, but a combination of them, and try to get you to write them into sum and difference of logarithms, where it's a log base a of 2 and a log base a of 3. And so you're going to replace log to the base a of 2 with 0.301, and you're going to replace log to the base a of 3 with 0.477. So for example, in this first one, this is not log to the base a of 2 or log to the base a of 3, so I can't replace it with one of these numbers right now. But I can see that this is the log of a quotient, so I can write it as the difference of two logarithms. So this would be log to the base a of 2 minus log to the base a of 3. And then I can replace the log. So the log to the base a of 2 we know is approximately 0.301. And log to the base a of 3 we know is approximately 0.477. And so we can just put in those values. And then we subtract using a calculator. So 0.301 minus 0.477 gives us negative 0.176. All right, what about the next one? This one's not as obvious. It doesn't have the 2's and 3's in there. You're expected to recognize, ooh, 6 is 2 times 3. So this would be log to the base a of 2 times 3. Now I have the log of a product, so I can write it as the sum of two logarithms. This would be log to the base a of 2 plus log to the base a of 3. Then I can replace. Log to the base a of 2 is 0.301, and log to the base a of 3 is 0.477. And if I add those together, I get 0.778. All right, let's progress on to one that's a little bit harder. What about 81? 81, if I wanted to express 81 as maybe a product of 2's and 3's, or maybe just 2's or just 3's, or maybe I want to throw a quotient in there somewhere, what could I do? How could I change 81 to 2's and 3's multiplying together, 2's and 3's dividing, or maybe 2 raised to an exponent or 3 raised to an exponent? Pause the video if you feel like a challenge and see if you can figure this out. Okay, so hopefully you have maybe an idea. I know when I did this in class, somebody started with going, ooh, 81 is 9 squared. And then they were like, well, 9 is 3 squared. So 3 squared all squared is 3 to the 4. So that was where someone's brain went this morning. What else could you do? Maybe you'd look at 81 and be like, ooh, I'm going to prime factorize this. So I'm going to look for all, by prime factorize, 2's and 3's are prime, which is why it's a good idea to do this. So maybe I go 81 divided by 3 is, I don't know off the top of my head, 81 divided by 3 is, I need that one, 27. And then maybe you could look at the fact that 27 is 3 times 9. Maybe you look at 9 is 3 times 3. So if you do that from a prime factorization, you'd say, oh, 81 is 3 to the 4. Regardless, this one we don't care about the 2 at all. We could write this as log to the base a of 3 to the exponent 4. Now I can use my power rule to write this as the product of 4 times log to the base a of 3. And now I can replace log to the base a of 3 with decimal 477. And then 4 times decimal 477, 4 times decimal 477 gives me 1.908. All right, let's go on to some trickier ones. Log to the base a of a quarter. How can I write this in terms of log to the base a of 2 and log to the base a of 3? So again, anytime you feel like it, pause the video, give these a go, right? I'm going to tell you that I see this as a quotient first. I'm like, you know what? I don't like the way this is written. I want to write this as log to the base a of 1 minus log to the base a of 4. Because now can you see what to do? A to what exponent is 1? Oh, that's 0. Now I'm left with minus log to the base a of 4. Well, now hopefully you're seeing log to the base a of 4 is 2 times 2, or 2 to the exponent 2. So you'd have negative log to the base a of, I would go to 2 squared personally. Then I can use my power rule to bring that 2 down in front. So negative 1 times 2 is negative 2 times log to the base a of 2. Then I'm going to replace log to the base a of 2 with 0.3 or 0.0, can't say it, 0.301. And then I'm going to multiply. I would get negative 0.602. All right. What about this next one? Well, if you tried this already, did you notice that it was already log to the base a of 3 over log to the base a of 2, right? So right away, you should just go 0.40, I've forgotten what it is. Oh, 477. 477 is log to the base a of 3. Log to the base a of 2 is decimal 301. I feel like I wanted to double check. Yep. And then I can do the division. So I've got decimal 477 divided by decimal 301, and I get 1 decimal. Now, it doesn't say what to round to, so I can do whatever I want. Both of these are in 3 decimal places, so maybe I go 1.585. Maybe you notice that it's 3 sig figs divided by 3 sig figs if you're taking a science class and you're like, hey, I want to round this to 1.58 because the next number was a 4. I don't care, right? If I don't specify, you can round to however many decimal places you feel like. But why did they ask this question? They asked this question because they wanted you to look at this and see the quotient of 2 logarithms and think, oh, I'm going to do subtraction. But notice the way I said that. It's the quotient of 2 logarithms. It's not the log of a quotient. So when you have the quotient of 2 logarithms, you literally can't do anything except evaluate them. You can't do a subtraction out of it because it's not the log of a quotient, right? Same thing with this one. This one's here to trick you as well. Everybody goes, oh, I can make 5 from 3 and 2. I know that this would be log to the base a of 2 plus 3. Sweet, that's an addition of logarithms. Now I'm going to make it into a product. No, that's not the rule. The log of a product can be written as an addition, but the log of an addition, there is nothing you can do. Please don't do anything. One thing I see often, and I'm always hesitant to say it, is that people like to distribute the log through. They're like, oh, it's log to the base a of 2 plus log to the base a of 3. I'm like, logs don't work that way. This is not like a variable that you can distribute, right? It's saying that a to some exponent is 5, or a to some exponent is 2 plus 3. You can't distribute or do anything weird like that. But people just want to use knowledge they've had. Like, I totally understand doing it. But this doesn't help me at all. I can't write it as 2 single logarithms. So this one, I'm going to say not possible. Okay, I cannot evaluate this one because I can't make 5 into 2's and 3's. No matter how hard you try, you cannot find any combination of 3 to any exponent, 2 to any exponent to make 5. All right, last thing. These last things, don't stress. They're very simple. There are 2 rules. So 2 rules is that if you ever have log to the base a of a to the x, it simplifies to x. Why? Well, because of the power rule. If I was to bring the x down in front, this would be x times the log base a of a. Well, log base a of a is 1. So x times 1 is 1. So every single one of these, if you were to bring the power rule, right? If I brought the 8 down in front, if I brought the 3k down in front, if I brought the negative t down in front, I'd be left with log to base a of a, log to base 10 of 10, log to base e of e, right? So every single one of these, I get the exponent as the answer. So that's a rule. If you ever notice that you have the log base something of the same something, the answer is the exponent. But it's not a rule you have to know. Apply the power rule, right? Solve it for yourself. The next one's a little bit trickier. So for this next one, this is kind of a rule that you just sort of have to accept, but it's the same type of rule. So with this last one, we had the log of base a of a to the 8. The answer was 8. So what I wanted you to notice here is that the base of the log was the same as the base of the power. Well, same thing here. We have a base of a power, which is the same as the base of a log, just in reverse order. And the answer to this is going to be k. So anytime you have a base raised to a log of that same base, the answer is whatever you're taking the log of in the exponents. The answer is x. To explain this one is a bit trickier. What you'd have to do, let me take this one, is say, okay, I've got 4 to the exponent, log to the base 4 of k. And if I wanted to say, well, what does this equal? I don't know, it equals something. Let's call it x. And let's say if I wanted to solve this, I could put it in logarithmic form. So I could say log to the base 4, right? The base stays the base, of x equals log to the base 4 of k. Well, to make this true, whatever is in the x spot has to equal k. And so that's why. It's a bit of a harder explanation. It's not using the rules we just used today, but you just have to know the rule. So this is e to the ln 5, which is log base e of 5. Same base. The answer is 5. Same thing here. We have 10 to the log base 10 of 7t, so the answer is 7t. All right, so give these questions a go. Do lots of these puzzle ones, right? Because the more you do them, the more you'll start seeing the pattern of, do they often make quotients or products, or, sort of, oh, there's a 1 there. Ah, that's always 0. Things like that can be really helpful just for making them feel really routine. All right, good luck.